these are the tasks of data scientists. And if you are not going to do this thoroughly, what will happen is like this. There are two types of people in this world. Those who can extrapolate from incomplete data. Okay. Two types. And that's okay. If you don't get it, it's okay. But if you, this I think you should get it. And there are people who might extrapolate like this. Yesterday you had 0 number of husbands. Today you have 1. So as you can see, by late next month you will have over 4 dozen husbands. So, because whatever you input in that software, it will give you some output. Okay? You have to think clearly about it. Okay, so in a nutshell, what data science is, and this definition is, I don't know why it is not there, it's a beautiful definition, it's not there in the latest version, at least when I checked last. Goal is in extracting meaning from data and creating data products, a product or a platform or a solution, whatever, and seeks to use all available and relevant data. You will have a lot of data. What data is useful, what is not? You have to think about all that thing. Okay? Relevant data to effectively tell a story, communication part concept, that can be easily understood by non-practitioners. Because your audience, in fact, most of the decision-making audience will be non-practitioners. They will be the business heads, okay, not your technical heads. But that's what it is. Take the data. You have a lot of data. Take the most useful data. It could be all of it. It could be part of it. Have a nice problem defined from that statement, for which you create a solution, and then once you build a model, explain it nicely to the decision makers. Storytelling. Okay. So that's what data science is about. So you'll see how these models can really be more powerful than even the experts. Pele, by far the best footballer Earth has ever seen. If you believe that. He has a tendency to make predictions before every major tournament. So he said, Colombia will win 1994 World Cup. Spain are favorite for 1998 World Cup. China will qualify for the next round in 2002 World Group. Argentina and France will both reach the final in the World Cup 2002. In all of these cases, all of these countries lost the first round. And then he said, Brazil won't even get past the group stages in the 2002 World Cup. Brazil went on to win the World Cup. So, and then what happened here with the latest World Cup? Microsoft Cortana or other kinds of series now is there. Google's platform. 14 out of 16, Baidu 15 out of 16. All these tools using data science techniques, 15 out of 16 games, 14 out of 16 games, they are predicted correctly. Okay. What things they are looking at, etc. is detailed, but at this time, data science works. All three of them, of course, got the Brazil versus Netherlands wrong. Okay. Past historical data, performance, and variety of things, whatever they might have considered. People's opinions, text, people are writing blogs, Twitter, any information you can collect. Based on that, you can make a lot of predictions. Okay. But the best thing supporting the idea of modeling is this classic paper that Professor Robin and Robin Dawes wrote, The Robust Beauty of Improper Linear Models in Decision Making, 1979. He was a professor in the University of Oregon when he started, and I think by the time he finished this work, he was in the University of Washington or somewhere. He was in Carnegie Mellon University as well. But this is a very powerful thing. He took the work from many other researchers, not all the work is his. But what he showed was And from multiple domains, from psychology, from education, from medical, from banking, everything. And he showed that simple, improper linear models were better than experts. So what he did was, he took data from about 60 companies, 30 of them had gone bankrupt. He knew that. He went to bankers, about 16 bankers from small banks, about 27 from larger banks or whatever. The ones who make decisions on giving funds or loans to these companies. When he asked them, who would go back, who would not, or whatever. And they were right about 72%, 74% of the time. But you would think, 74% might look very good, but you might think that those who are doing this day in and day out, they should do better. So in any case, what he asked was, what are the factors you are considering to make your decision? And they gave him about 5 factors also. He created an improper linear model. A linear model, improper means, he said, okay, all these factors have equal weightage. When we will learn linear regression, we will see the weightages to each of the variables are given based on the data, etc. But he said, let's give it equal weightage. That's improper. A proper one would be done properly. Improper, give equal weightage. He did that. And he outperformed the experts. The models outperformed the experts. He took it to doctors. For patients, 193 patients who had Hodgkin's disease, all of them had died. And he wanted them to predict survival rates based on the severity of the disease, etc. And 0%. How long the time to survival? There was 0% correlation between what the doctors thought and what it was. Created a model. 35%, 40%, something was much better correlation. A model was able to do better. Okay. Education. People who are being admitted into PhD programs. Admissions committees making decisions. I should be taking them, I should not be taking them. Correlation between what they have taken, the people who have taken, and their performance, the final output, etc. Models did better. So he did it in multiple human relationship between married couples and all kinds of things. Everywhere. And models were outperforming. So he said that's what it is. The robust beauty of improper linear models and decision making. We have to have some nice titles to get published. The purpose very impressive, but some nice title. But there is nothing there. Improper linear model, where all the factors have been given equal weightage. Just that. So what he concluded was, simple models do better than experts. Very, very simple models. That doesn't mean that experts are useless. What it meant was that human beings are very good at understanding what is affecting something, what is affecting the output, what are the variables that are important. Those variables he collected only from those experts. But when multiple variables come together, they are unable to process the impact, various impacts of all of them together. They are not that good at that. That's where my mathematical models are going to be helping out. Identification of that. So humans are important, experts are important. They know their stuff. They are not idiots. They know what they are. But use the models to help with that decision making, because then you are bringing both your knowledge, intuition, experience, and now you are listening to the data. That's what is important. Okay, so what types of data science problems that we are looking at? First thing we will learn, simple descriptive statistics. Just describe the data. Description could be as simple as that. Count how many matches total India played, in how many of those Kohli scored more than 40 runs in World Cup T20 matches, and how many India won. Simple analysis like that can show things like that. Okay, so that's some description, some basic analysis, but very good, very important to get some understanding of the data, some insights about the data. That's descriptive statistics. We will see that. That will be part of any type of statistical analysis when you do, even if you are doing regressions and predictions will be output for you to take a look at it and understand something about the data. Then we saw prediction, classification and optimization. Classification can be of two types: supervised, unsupervised. When it is unsupervised, we call it clustering, and there are other techniques in unsupervised machine learning. But essentially at a very high level, this is all the data I have. Let's say some customers who buy products from my e-commerce site or something. I don't know anything about the data, but I throw the data at my machine learning model. I throw the model at this data, and it says these people are similar, these people are similar. It is clustering them. It's saying this group is similar, this group is similar, based on some mathematics, which you will learn. Now, but you don't know what is this group, what is this group. Now you go look at the characteristics of this group. Oh, these are all the people who are not buying enough from my thing. So these are my low value customers. These are the people who are, that is a clear difference I am seeing between these two groups. These are the people who are buying a lot from me. These are my high value customers. Now you have defined them. You have given a class variable or a target variable. That's the names that are used. The dependent. We are saying this is what is the class or the name of this group. When we say class, it's a name. Essentially, we are giving it a name. That's what the classification is. These are my high value customers, these are my low value customers. But beforehand, when the data was given, I did not know that. In which case, it was an unsupervised one. But suppose I already knew from the past data, I knew my characteristic. If people do not buy frequently or spend very little money, or they have not come to my store recently, there's got RFM analysis in commerce, retail industry. The recency, frequency, monetary value. Don't worry too much. Recency, how recently has a person bought? How frequently is the person buying? How much monetary value is the person giving? RFM. So let's say I have done that analysis and I said, these are my low value customers, these are my high value customers. In my data, I have a column already defining them. I have a column for the customers where I am collecting the age, the income. Some people may give, some people may not give, education level, whatever, what products they have bought, and whether they are high value or low value customers. The last column also gives me a class already defined. If that is already defined, I now use my models to train. I know who are high value, who are low value. And then, based on that, the future customer that comes, to predict whether he is going to be high value or low value based on other parameters, I can make a prediction or classification. He is a high value customer. No, he is a low value customer. That's supervised because I already knew what I am looking for. I have already defined what is high value, low value. That is supervised. In the first case, I have not defined anything. I don't know anything about the data. I said, find me similarities, cluster them. Okay, these people are similar, these people are similar. These two groups are very different from each other. Now I have to say, give it a name. Okay, what is this? So that becomes unsupervised. Okay? And there are some other unsupervised techniques that we will learn later on. But this is classification essentially. Low value customers, high value customers. Not having diabetes, having diabetes. Will not take a loan, will take a loan. What? Nice. So classification is nothing but you are partitioning the space. At some point below this, these are my low value, this is my high value, something like that. It's partitioning. It need not only be a linear, it can be multiple dimensions. Logistic regression is a linear. We will see decision trees is a very non-linear partition. I'll show the visuals of that as well. But classification. These are, so I can classify by this thing. Classical, these are money devoted, I think various ways. Those who spend less money on clothes versus those who spend more money on clothes, or based on age. These are slightly older women, these are the younger women, or these are more classical. If I divide by this, these are classical, these are fashionable or original, these are superstars here, whatever, multiple ways I can segment it. Based on these parameters, I can classify it. This is the non-linear way of doing it. You will learn in decision trees how this is non-linear. You might think all are straight lines, but here I am saying if x-axis is less than 0.5 and y-axis is less than 0.5, then whatever the class is, then the education, then they are very low value customers, low value customers, medium value customers, high value customers, whatever. If x-axis is less than -1 and y is less than -0.5, or if y is more than 0.5 and x is less than 0.05, then it is 4, something like that. It's very, very non-linear. You will see that's a typical decision trees is what you will see, but it's a classification model. That's where Dr. Sriram Murthy's oblique decision tree. He said, why do I want to have these parallel to the axes? Why can't I just cut it at an angle using linear regression? That's where you will learn in this course pretty much. Mix and match things like that. So he used linear regression to do something and then use those lines to partition the data. So that I can partition it in much fewer data. Of course, then the model becomes a bit more difficult to explain also. All these factors come. We will cover all of that. Okay? But this is classification. Okay? Segmenting, partitioning into different groups. That's all classification is. Okay? In one word, one sentence, that's a classification. Will he buy or will he not buy? Is he a low value customer, medium value customer, or a high value customer? That's it. Classifying groups. A prediction or a forecasting, you said y is equal to mx plus c. That's it. I have data, I've got it, and now I want to predict. Someone, if the concentration of the asset is here, how much will my metal degrade? Or if the income is this much, how much loan to provide? You just read out the answers. Okay? That's prediction. Forecasting, time series forecasting, we will cover in 4 weeks from now, 3-4 weeks from now. How do you forecast? Based on the historical data itself. Okay. What will be the revenue next quarter of the company? How much product sales will happen next 2 quarters? What will be the stock price next month? Variety of things. Optimization, another type of problem. How do you use your resources optimally to maximize profits? Now you are advertising. Should I put maximum money on a hoarding and some in social media, Facebook ads, some in paper ads? How much money to put in each? Because I have total $1 million, 10 lakh rupees or something, 7 crore rupees, whatever the amount might be. How much to put in newspaper ad, how much to put in Facebook ad, how much to do? It's a very, very important optimization problem. For that I need to understand the data. How many people are booking tickets online using tablets? How many people are using desktops? How many people are using what kind of a operating system or whatever? All this is being collected, information is being collected. Web is being done. Ads are being shown to you very differently. You go and search for something on Flipkart or Amazon, and then from whatever website you go after that, you see only that. Okay? Variety of things. Okay. So, lot of data being understood to give you the ads correctly. Okay. So that was the types of problems. The prediction, classification, optimization. That's what any data science problem will fit into. Some applications in various industries. Churn. And telecom churn is a major problem for telecom industry. Banking also. I recently closed a bank account and the manager called me and he said, he used the words, he said, it takes us a lot of time to get a customer. So keep the account, don't put any money, just keep it in there. When you need, do something in there. I said, it's been years I have not put any money in there. So, not needed. I had a home loan that I moved to another bank. I said, that was the one thing, one reason I was still continuing. I don't need that also. Close it. But he mentioned that it takes a lot of money to get the customer. Telecom churn. In general, the industry problem is 3% per month people churn out. In a year, approximately 36%. More than 1/3 of people are churning out to a different company. Churn is going from one operator to another. And with this mobile number portability, that has increased. This is a global thing. 3% per month is not just in India. Globally, that's a problem. And that's a huge problem because the average revenue per user, at least in the Indian context, a few years back when we were solving this problem for a major client, that client had 8%. And years at that time had 8% churn per month. In a year, they lose all their customers essentially. Someone else comes in, but acquisition cost is huge. So, average revenue per user was 170 rupees approximately per month. That's what they get, 170 rupees per month per customer. And the profit margins are not huge this time, maybe 10%. So 78% or 70 rupees or something per customer they are earning in 1 month. Now the acquisition cost was 5 times the ARPU, they call it ARPU, average revenue per user. 850 rupees. 850 rupees to acquire a customer. You are making profits of 70-20 rupees per month. When will you make that? Okay. So you need that long an association before the telecom company will start making some money off you. And if you churn out like that, they lose a big money. Of course, someone's churn is your benefit. There is more complexity. Some people are coming to you without even you trying. But in spite of all this, telecom churn is a major headache. So now 36% per year. You don't solve it again, but it's a multi-billion-dollar problem annual. You bring it down from 36 to 30. You have done a remarkable thing. So that's the kind of benefit a data science can give you. So churn can be hard to correct. Retail analytics. Your shopping habits, if you think your life is private, no more. Anyway, the moment social media is there. This was a cover page of New York Times magazine in February 2012. Hey, you are having a baby with all the products there. How many of you know this story? Okay. So Target is a retail chain, and the story goes like this: that there was a father of a teenage girl who barged into a Target store and started picking up a fight with the manager because his teenage daughter was receiving pregnancy-related coupons, very specific things. And he said, "Why are you sending this to me?" What would the manager know? Some data science team of Target in India must be giving some things and say, "Okay, you send this to them, you send this to them." He doesn't know anything. But a few weeks later, that same gentleman, he came back and he apologized. He said, "I'm sorry. Yes, my daughter is pregnant." So Target found out that this teenage girl was pregnant before the family would find out. Power of data science. How did they do that? Because historical data shows that women over the 9-month pregnancy period, they are buying different products. When they are just get pregnant, there are certain products. By the 9th month, there are a lot of diapers coming in. So there is something going on there. And they have classified. Pregnant, not pregnant. Okay, 2 buckets. And based on those patterns, this girl, the moment she started buying some things, she fell in that bucket. Oh, she's pregnant. So they are sending her coupons. Okay, so target gets to know much before. Now this is not just as a data science problem, it's a remarkable thing. It's very simple analysis. You will learn how to do that. But it gets into other problems that the data science community has still not figured out. The ethics and the privacy kind of problems. Now, the problem is, Target is selling legal products that they want to sell. They have the authority to sell what they are selling. Milk and this and bananas, whatever. They are giving coupons to a girl. The girl needs those products. She needs those products. They are giving her coupons so that they can get it cheap. She can get it cheap. So girl is benefiting. They are not selling anything illegal. The girl is benefiting from that. They are selling the right products. But yet, they are invading her privacy. They have no right to get into her private life. That's a huge thing. What should we do? There is no answer to that. People are still struggling with that. So, everything nice, everyone is getting benefited. Target is getting its customers, the customer is getting products that they want at cheaper rates, and yet privacy problems. So, but data science things, they can solve these problems. Okay? Google Trends, the text mining, text analytics can come into play. Center for Disease Control must have a multi-billion budget, annual budget for all communicable diseases or any diseases that are increasing. They are in charge of that. But Google found out the flu was increasing 2 weeks before the Center of Disease Control could figure that out. How? Very simple, very, very simple thing. Now, when I am suffering from flu, we are all doctors now, when I am suffering from flu, okay, what medication to take? I am searching Google. What home remedies can be done for flu? I keep typing flu. Suddenly they see a spike in searches on flu. Why would I search for flu when I am not suffering from flu? I will be searching for it only when I am suffering. Immediately they know that more flu is spreading. Center for Disease Control is still collecting data. Google finds out. Much better. Very simple analysis. Simple models outperform experts. Not only that, Google searches can predict stock market crashes. I am losing my job. I am in more debt. I am unable to pay my loans anymore. Things are becoming more expensive. I am typing all those things. No, debt and these kinds of words show up. And people can actually make money out of that. There are multiple strategies. Buy and hold strategies. So this is the red line over 7-year period. If you just buy and hold, people like me do this thing. And they don't earn anything. So 16% after 7 years or something. Then mu plus sigma, mu minus sigma, we will see that. Mean and standard deviation. Mean plus standard deviation. It's so important. That's all there is. And that is the dotted line. Okay, it will give you something more. Of course, you can lose more also. We will talk about that range. Okay? And then Google Trends strategy. If you see these words, sell it, market is going to crash. If people are searching for debt a lot more, sell your stocks because the market is going to go down soon. And then once things pick up, you buy it because it will pick up. And if you use that over a 7-month period, 326% profit. People can do that. So text analytics can give you those ideas or those insights, what might be happening before things happen. Recommendation engines. People who bought this also bought these kind of a thing. We will see association rules and other kinds of things we will see where you can build those models. Very simple models. Text mining. Are Americans happy or not? This was a very nice study that was done. If you want to know in the last century, Americans' happiness index, how did it go up or go down? How would you, if you want to find out were Americans happy in the last century, what could you possibly do? How would you go about solving that problem? Surveys, you can do some survey. Are you happy right now? Right now you can get, but in 1900 were you happy? I was not there in 1900. I can't get some of the data. But are you happy or not is the survey I can do. To just find out are Americans happy or not? And the easiest thing is I go and collect the survey. What else can be, anything else can be done?
Standard of living of people.
Standard of living is increasing.
Our countries in the
Events that have occurred. Employment rate, some of those things you can take a look at it. You can relate. Employment rates are going down. People are more unhappy probably. But all these studies will take a lot of time. This kind of a study was done in a day. In a day or 2 days. One thing is, there is already Google or there are some universities that these digitized books are there. They took books written throughout the century. All that has been digitized. So each word is available. And then there are these corpus of words and their sentiments. There is another thing already defined. That this is a positive word. This is a negative word. So if you say happy, happy is a very positive word. If you say anger, a negative. Every word has some connotation. Whether it's a positive word, negative word, or a neutral word. And all these words in all the books, that's also is available. How many times each word appeared in each book. So now what this is, let us assume that books written in a certain time period reflect the moods of the people at that time. You have to always make some assumptions. It's a reasonable assumption. So let me do that. And then they did that, and based on that, this is what they came up with. And if you see, Americans, and this is some Z scores, we will talk about that in statistics. Again, using mean and standard deviations only everywhere. We will calculate joy minus sadness. Some standardized score about that. 0 means joy and sadness. Nothing. This is joy minus sadness, so positive, so more joy, more sadness. And you see, around 1930, 20, 30, 35, around 35 onwards, or even before that, 1930 onwards probably, things are going down. Great Depression. America was in the middle of Great Depression. Then the World War. World War ended around 1945. And that's when things started picking up. And then in the middle of the 1980s or something, again, America's manufacturing industry was in a big problem. They were thinking, actually, more than manufacturing the real estate. They were worried that Japanese are going to buy America. There were Japanese are buying lands, etc., and all those real big problems they were facing. So things were coming down again, and again going up. So, but a reasonable linkage, and that's all you should be looking at it. You made an assumption, you thought out of the box, you used the books written at the time as a measure of the sentiment of that time, and then you came up with some chart. And now you are linking with part of the chart with some events that have happened, major events. Things seem to be making sense. Okay, fine. This is my analysis. A quick analysis. Nobody can guarantee anything. Quick, nice analysis. Out of the box thinking. Essentially. That was all done using text mining. So many applications are there. We can go on and on with these applications, but quickly, many of these things that our teams have in the past 10 years, when Mahesh is sitting there, who has been with us for the past 7-8 years, 2009, Mahesh? 7-8 years, before Insofi. So many other problems have been done by them. The fraud detection in clinical trials, I think, was done last year. No one tests, etc. Many problems resolved. Drug development process. Drug development process is a long process, multi-billion-dollar process. It takes 10 years or so to develop something, which involves a lot of failed experiments. And Dr. Dakshinamurthy's relative, he was a professor in MIT, and then he came out and started a company, startup in that thing, and he was mentioning, if you can predict upfront which experiments will fail, if you can do that, and if I bring that 10-year time period down to 7 years or 6 years, I am saving $3-4 billion. 10 years, about $10 billion, almost $1 billion per year. That's what happens. So, I can save that much. You tell me upfront, based on the past failed experiments, if this is showing similar patterns, then this is going to fail. I will stop that experiment right now. I won't continue. Okay. Things like that can be done. In automotive industry, very recently, we were looking at it. When I was doing my PhD, my work was on building anti-tank projectiles, or seeing how good they are. Anti-tank army tanks, how to blast them, basically. So explosives and all those kinds of things. And so, what we were doing was, we started doing computer simulation. Because actually doing the test is very expensive. Physical experiment. So they do very few physical experiments. Simulations now can help. And I was where it doesn't take that much cost. I can create computer models and I can do that. But my work was in trying to understand, linking the physical process with the simulation, understanding both of them. What I found out, I thought the simulations were saving time and cost. What we recently found out from this automobile company is that simulations themselves were now too expensive. Some simulations take 2-3 days to finish, and they have 330 parameters, variables. Each variable has a specification limit. They have to tweak to find out how safe the vehicle is, the car is going to be. And then they said, can you do data science to minimize my simulations themselves? Tell me what are the essential simulations that will cover this entire spectrum of the data. I don't need to tweak every single thing. Tell me. So we looked at some past simulations, and there was a platform also. I think they are still building. Radha is sitting there, and she was building a platform that helped identify, minimize the simulations. Okay, instead of doing this 300 simulations, you do these 70 simulations that will cover the entire space. A lot of time saved, a lot of money saved already, a lot of benefit. So, those kinds of things can be done. Healthcare, we just saw non-adherence. Banking and insurance, again, fraud detection. We were working on this problem some time back. Credit scoring, cross-selling, upselling. So, people who bought this are likely to buy this, show those things. Forecasting stock prices, improve customer experiences. So, which hotel, people go to various hotels, they stay during the travels, they give some feedback. They have a profile, each customer has a profile. Which type of customer is preferring what type of a hotel, so that I can recommend the right type of hotel upfront. So, things like that. Politics, of course, Obama, that was the classic case where a lot of data science was used to really win the US elections. And again, the BJP also used, not at that level, but quite significantly, it was used in the last general elections. What Obama was really doing was, the Democrats were anyway going to vote for him. Those who are hardcore Democrats, they will vote. Why should I spend too much time? Hardcore Republicans are anyway not going to vote. Why should I try to convert them? There are enough of these fence setters who have local problems. So this data science team, and if I just generally talk about my overall plans for the country, they don't care. Each person has specific problems in their locality. So when he was traveling around, the data science team was able to figure out based on the blogs and the other local newspapers, whatever was being talked about, what was really significant to these people at that time. And he was just talking about those. A lot of health setups were really converted. That was a major benefit to the Obama campaign. So, everywhere. Retail, telecommunications, the customer retention or churn, supply chain efficiencies. We were recently talking with a major e-commerce where they were saying, see, we always say you will receive your product by this date. And invariably they actually give it earlier, which is needed for customer experience. But still, that is not as effective for them. Where what they were saying was, will you be able to tell me, I should be able to predict and tell the customer that you will receive a product between 3 o'clock and 4:30 on this date. Can you do that? We can do that. At that level, you will be able to do using your data analysis. And that is very important to the customer because the big billions here that happened, I bought a few things. Now my wife is stuck at home because every day we don't know which day what item will come. And in spite of that, yesterday my wife went out for something and that's when the Amazon guy called me and he says, I'm standing outside your door, nobody is picking up. Really, okay, they'll give it to the neighbor and they give it. Sometimes they don't. But if I knew that they will come between this time, I can plan all my rest of the time very nicely. Much better experience. I would love to switch to a different e-commerce retailer if that can be given to me. I will jump. Government policy planning, we are doing it for Bahrain Economic Development Board, some R&D work at this point after corporate training we did for them. So their economic planning, etc., how we use data science there. Yes, just doing that. I think one of the data scientists was working on that project and talking about that. So it's more of R&D this time. There is no real product they are building. It's continuing R&D work that they want us to do. Okay. But policing, security, terrorist attacks, etc. AP police, when it was Andhra Pradesh a few years back, so 6-7 years back, and SP or one of the very senior policemen called us here near the CM's office, actually, camp office, and they were talking, and I both Dashnamurti and I went there, and we were impressed at the level of technical knowledge this person had and what he planned. He said, we have a lot of audio recordings, all these Naxalite problems that he was trying to deal with, and he said, we have a lot of audio recordings, but we have to manually go through them. People talk, they won't say, no, I'm going to bomb this person, I will be delivering sweets, or something like that they might be talking about. So all these things are there. Can you do analytics to identify what is happening? He said, I have all the technology to actually hack anybody's phone. He said, I can get into each Naxalite's phone calls, etc. I have all the things. We have tons and tons of CDs and everything put up there. I can do all that. He said, I don't need it. I can send a virus easily. I can do whatever. Everything is easy enough for me. We have done that. What we cannot do is manually listen to all these recordings and then make sense. You do analytics. Of course, the project never got started, but the ideas were there and that can be done. Okay. Chicago Police since 1990s, I believe, has been using to identify on which day of the week and what time, which area in downtown Chicago will have more crime. Send more police there. The data is there, no? The patterns are there. It's not very difficult. Every Friday evening or whatever, near the pubs or what areas, more crime happens. Some things like that can easily be, patterns can easily be identified. Some patterns may be very easy. They may know without doing data science. Some are very complex. That's the problem. A doctor may know that a woman who smokes during pregnancy will cause complications. But a doctor also may not know that a woman whose blood group is B positive, that's an example I show sometimes if I teach association rules and other things. But if a woman is, the blood group is B positive and she smoked during pregnancy and The kid now, the kid is born and everything is fine. Kid eats a lot of carbohydrates, then the kid has a high likelihood of getting asthma. That the doctor may know. Doctors have indicated. These kinds of insights will not be easy. They know pregnancy, yeah, this will cause complications. All those complications are known. Nobody needs to. But if there is a B positive versus an O positive, may not have that impact. O positive woman smoking may cause other problems, but a kid contracting asthma, that will not happen. You know, these kinds of very nice insights can be obtained, which experts will not know very easily. And other benefits. In fact, one of our students in the 8th batch, brilliant guy, he topped actually, but he was suffering from cancer actually. And his doctors had advised he may not be able to do this rigorous course. And he took it as a challenge. And he said he would not be able to sit. And we did not even know. In the middle of the program, he told us. And and he did the whole program and he was thrilled with it. But in between, he had been having his chemotherapy sessions as well. And sometimes in Chennai, once he told us he was admitted for a week or so. And so what he said was, during that time, he actually advised the doctors, because this non-adherence and all these things we were talking about. He asked doctors, are you facing similar problems? And they said, yes, we do have problems like this. And he took some data from them and he actually gave them a reasonable solution during his stay in the hospital. He came back and he said, the doctor was, next time when I went for the treatment, I asked him if the model is doing fine, is predicting whatever it is. And the doctor said, yeah, it's having pretty good benefits for us. So simple things can be done and simple problems can be solved. How long will a patient stay in the hospital? That you can predict. Based on that, your beds and all those kinds of things, you can plan for that. The data is there. Now you will learn all that. There are two problems. One is data collection, one is with the available data what you can do. This itself is a major thing. The data is available. Which parameters, etc. Now, for what type of problem? That's where you have to first define the business problem. You can solve with the same data 100 different problems. What data to look for? If you don't have data, then you can only advise the customer to start collecting data. But that is not our business at this point. There is enough data. How to identify what is important, etc. We'll learn all that. But I'm just showing the applications across domains, across everywhere. Weather predictions, very difficult. This is still a very complex thing. Calamity predictions, very, very difficult. Mostly impossible. But people try to use that. And when will the tsunami come? Or when will the next earthquake happen? A lot of data being collected, but still very rare events, very difficult. I don't have a lot of historical data that I can find nice patterns. Very challenging. Things like that I've worked on. Smart cities is going big, and obviously without data science there won't be a smart city. All the technology is available in fact. There is nothing new to be done. Sensors are available. Sensors are and they are very cheap now. You can put sensors in everything, start collecting data. Now all this data from multiple things has to be brought together and they have to talk to each other, and then you have to get insights not from the individual components but from everything talking together. That's where I think my belief is that you need new applications. The data science is available, the sensors are available, the data is available. You need new technologies to make the city smarter, to make them talk to each other. Nothing new has to be bought. This is not rocket science anymore. This is in the realm of what is being done right now. It's there. And finally, what we will cover is a lot of big data. All that big data. For the past 2 years, we have been hearing these comments that the data generated next year or this year will be more than the entire data generated from the start of humanity till now, till last year. All the data put together, just this year, it will be more than that. And next year, will have the same statement again. More than all this. That is the rapid pace at which the data is growing. So a lot of nonsense is also being collected. We are not deleting anything. All junk is also there. Sifting the good data from the bad data, managing that data. That is where the challenge is. That's what we'll cover. Obviously, it's a continuous learning process. So data is everywhere, you can't escape it. And as a data scientist, you can make better decisions than many of the experts, for which the skills you need to know, apart from what we have covered, the technical skills within that tasks of a data scientist we covered, statistics, very, very essential. That's what we'll get started with tomorrow. Machine learning will follow. Many techniques in machine learning, including the latest deep learning and variety of neural networks, even within the regression. I will talk about the linear logistic regression that the world does. Later on, Dr. Darshanamurthy or someone else will talk about ridge regression, lasso regression, some other enhancements to those things, some other techniques as well. But apart from that, decision trees, random forest, ensemble methods, SVM, neural nets, deep learning, many other things. Communications, we will also share you one module that is I used to teach, but that was the last class. I think just like today's session, not much of interaction. From tomorrow there will be interaction. But there is a video on communications, ethical, IP and legal issues that a data scientist should be concerned with. That you go over the video at your convenience. But that class, physical class, I have replaced with a visualization, which is actually a significant communications. So some of the things are common in that class and what I will be covering here, but a lot more visualization principles as well we will cover. So that's something we will do. And understanding customer domain, we can only emphasize it. You have to keep asking questions in the domain perspective. There is not to be taught much, but lot to learn. Asking the right questions of the data. So this is what we will be covering, and by the end of the 6-month time period, you will be drowned in information as well as light. So we'll actually both will cover. Okay. So before I close this session and then start with some statistics, terminology, etc. That's what we'll get started today. But one thing you should be cautious of is when we start seeing the data science outputs, you should be, sometimes you just might think, oh, nice insight. But you have to be a bit cautious. A statement often made is correlation is not causation. This is an example from the 1940s when the doctors in America were recommending people not to eat ice cream or drink soda because they saw a strong correlation. Technically, what is correlation we will define later, but English, they saw a strong correlation between ice cream sales and polio cases. So they said ice cream and soda was causing polio. Do not drink them. But now we know that is not true. What was true was, if you looked at the x-axis also, from July to September time frame, ice cream sales were increasing because summer months in US. That's the summer in US. Polio also was increasing. So summer was doing something to the polio virus. The polio virus was more active in summer. So both those things were being caused by the weather. Not one thing was not causing the other. Oh, that's a nice rhyming thing. Both the things were being caused by the weather. One was not being caused by the other. Aha. Oh. What do you say? Say something. Irshad. Okay, Irshad. Okay. Good. Anyway. And I'll show you a lot of newspaper cuttings in the next couple of days or during the stats module. Life expectancy, black males and black names from 1802 to 1970 in 4 different states. This was from, I took a picture from a newspaper, Deccan Chronicle, a couple of months back. This is life expectancy. These are Alabama, Illinois, Missouri and North Carolina. The blue are all black males. The reds are black males with black names. So traditional African Americans having traditional African American names. Life expectancy, you see in all these 4 states over 170-year time period, people with black names are living longer. So if I am an African American and I want my kid to live longer, I just have to give him an African American name. Not the new fancy names. No, but that's again correlation. The data size is good. I mean, in 4 different states, it's clear. The insight is very clear. But what it might tell me, when I have to analyze the output, I should not just project it like this. This is wrong. What I have to think is, why is that happening? Maybe because those who are having traditional names also are following a different type of a lifestyle. That might be causing the life expectancy to be higher. So that is the real cause. Just having a name is not the cause. Okay? Blacks is black names. But people always can send you a message like this. Then it will be idiots. Okay? So that's what this part of the presentation is. I think it's 12 o'clock. So for 5 minutes, if you want to stretch your legs, you can, and then I'll start a new presentation. I will not finish that. It's okay.
One quick question.
Yes, please.
What is the difference between big data analytics versus data science?
Nothing.
Is it the same or?
Buzzwords. Don't get caught in buzzwords. Different people will use different terminologies as per their requirement. Unless you go into the depth of the curriculum and the top topics, you will never know. So, when we started the program, data science was not there. The terminology data science was not there. In fact, big data was just developing at that time, 2011, when we started. People were beginning. First batch, we did not have a big data module, in fact, at all. Hadoop also was not known. Second batch, when we were there, some of the students came and said, oh, there is some talk of Hadoop going on. Can we not have that? Dr. Sriramurthy immediately, we extended the program by 2 weekends, 4 classes he added in the Hadoop thing. And that's how it started, and then now it's a 10-day or 11-day module with the latest and the greatest incorporated in that. But the thing is, it's evolving so fast. MapReduce was a huge thing, and we used to spend a lot of time on MapReduce. You will learn about that. But now, it's not needed as much. They have come up with components that can do the job much more easily. And so, people not having that level of programming knowledge, of course for big data you need to be good at programming, but in not having that could use some of this thing and still be able to do the job. So high event pick and other things came. But then, so what we have done in our program is we use some concepts we talk about in depth so that conceptually you are very good, and then we introduce a lot of the other tools, so even the latest ones. But then we won't go into a lot of depth into some of the tools because in 3-4 months there will come. A new thing will come. How to be able to handle that new thing that comes easily. That's where the focus is, with enough focus on doing thorough job of some of the tools that are being used big time. So that's how it's been structured, but we have all the latest and the greatest kept on adding. That is so, but at a high level, the way we do it, when we say big data, we are, from Insofis perspective, we are talking about Hadoop and Spark ecosystems and all those things. So data engineering, not analytics. The rest of the thing, when we say data science or analytics or something, it's all the statistics and machine learning components that are there. But someone else might just do say big big data is the whole thing. Data science in general is the overall thing where everything comes in. The big data part, the analytics part, but analytics and some people say business analytics, some people say data analytics, and some people try to find out the differences between them. I don't know the difference. Those who want to show the difference, they will say, oh, business analytics is focused mainly on the business concepts of that. So what you are being taught in business schools, they won't get into the technical depth. Data analytics is where you get into the technical depth. I don't know. So that's where then many people who want to go to US and I advise them, they'll say, oh, this university said it's a business analytics program, this university said something else. As a university saying something that has no meaning, go into the curriculum, see at what level they are teaching what techniques. Then it is that. So terminology is interchangeably used. At some level you can show some differences, but there is no difference. But there are two major angles to that. One is data engineering, one is the data science, if I want to say, where you are managing and dealing with the data, which is what our big data module is. The Hadoop ecosystem and the Spark ecosystem. That's more of data engineering. The rest is data science, if you want to say analytics. Okay. So, let's take a 5-minute break and I'll just switch on. I've switched on to the other one. Just quickly 5-minute break to stretch if you want. If you don't, I can go. Live with me. Yeah. So, okay. So, in case I fall sick or something, you know there is someone else who can handle that. Very good. Okay. So now we'll get started with some basic statistical, because there are many people who don't know statistics, who have said they don't know statistics. So some terminology. So today we will not get into any understanding the data or anything, but some understanding the language of the statistics. But before we get there, some motivation. Why do you want to learn it? Because when we learned it in school, it was all theoretical nonsense. But why? There are three kinds of lies: lies, damn lies, and Mark Twain said it was the British Prime Minister who said that. Lies, damn lies, and statistics. So you have to learn how to lie. Okay, so that's why you will learn statistics or how to identify when people are lying. So that's more important. Okay. So, and I'll show you why that is so. Why people link lies with statistics. And this was an article at the time of the last general elections. The sex ratio of electorates used to be tilted to the male voters, but the trend has started to change. 5 of the 13 states, along with the 3 union territories which went to polls in the first 4 phases of Lok Sabha, experienced female electorates outnumbering their male counterparts. And I'll show a lot of these newspaper articles to show that the statistics is all around you. You are dealing with it day in and day out, and how people are just messing it up all the time. I will prove to you from now on, after today's class, you check numbers. Whenever numbers are thrown at you in the newspaper every day, I can guarantee you one mistake will be there. Guaranteed. You will not find a news article where everything is completely true. You may find, but at least in the total newspaper, you will find a mistake guaranteed with respect to numbers. So this is the article, and they said in Puducherry 52% female, 48% male, and this is what they are using this data to justify their statement that more and more females are voting compared to males. And at first sight, it looks right. And most of the time when these things are shown in newspaper or certainly WhatsApp 99.79% is anyway checked. Whenever it comes to data, it does guarantee wrong. But newspapers, blogs, many times, they are used to mislead. Okay? So, the first problem comes, but at first sight it looks like it is right. More females than males. There is nothing wrong, and we will just read the article, we will move on. We will say, yes, more females are voting. So, what I did is, I actually checked the Election Commission's website, and by April 24th, when I first looked at the article and then I copied it again on April 27th, when Puducherry went to polls, this says 5 of the 13 states and 4 phases of Lok Sabha experience. But actually 6 phases had already polled. Not 13 states but 19 states, not 3 union territories but 5 union territories had completed polling. Very importantly, Daman and Diu had not even gone to polls. According to election website, date of polls 30th April. On 27th April, and this is height of predictions. Data science taken to a new level. So, it had not even gone to polls. They are saying in Daman and Diu, 50.5% females voted. So, data gathering, they must have collected data from somewhere else. Past data. So, in problems with numbers, first thing in data gathering, there are a lot of wrong information that is collected. Okay, that's the first thing. Then I started looking at it, and the second problem was, when I started looking, I said everything is adding up to 100%. That doesn't sound right. See, the thing is, percentage should add up to 100%, but the problem they are saying is more females are voting compared to males. So I have to see if among all the women, let's say 80% women are voting, and among all the men, 50% or 75% are voting, then I can compare. But what this essentially was, when I looked at again the website, I see that Puducherry has 52% registered voters who are female. So let's say in a place, I will just magnify the problem. I will say 75% of the voters are female. Registered voters, and 25% are male. Now, among the people who will vote, if I just look at the percentages, well, the women will look more. There are more women there. If there are, in 1,000 people, 800 people are women, let's say, that won't be true, but 800 people are women, 800 are women, 200 men. Out of 800, let's say only 400 voted. Out of the 300 men, let's say all 300 voted. If I say more women are voting, that's not right. Only 50% of the women have voted, 100% of the men have voted. That is what I should use. But these numbers are just the percentage of women and men electorate in that thing. 52%. 52% there. 51.76 in Kerala, or 51.8, 51.9, approximately there. Manipur 51%, 50.9 female. Only Daman and Diu, which had not even gone to polls, had a lesser electorate. This is not among the people voting. So these numbers are just reflecting the registered voters. Nothing to do with the story that more women are voting. There's a percentage of the women registered voters. For the story, what I have to do is how many voted. So, of the registered voters, so 52%. So this is what the same thing basically. So say it is just reflecting that essentially. What we need to understand is this part of all the registered voters. So that was data understanding. I didn't even understand what data I am collecting. data analysis is very important. That's where the problem mainly lies. I went to the election website again and I collected data from elections conducted in 2006. What types of elections? Assembly or general elections, whatever. For each of these states. And then I saw whether really females were now voting more and more compared to the previous elections. What I see is the blues are where females out voted more. So 84.48 here means of all the registered male voters, 84% voted in that election or in that series of elections. Of all the registered male voters, 84% of them voted. But 86 voted. So Puducherry from 2006